Mouser Electronics is an authorized semiconductor and electronic component distributor focused on new product introductions from its leading manufacturer partners. Serving the global electronic design engineer and buyer community, its website features more than 5 million products from over 1,200 manufacturer brands. For more information, visit Mouser.com. All right, guys, I'm Nicolette, and today Brian and I are here with Anders Hardebring. He is the CEO and co-founder at Imagimob, and we are going to talk to him a little bit about TinyML and the world of machine learning and AI and everything that's happening there. It's a very exciting time for us. So thank you very much for joining us today. We appreciate your time.
Thank you.
Why don't you kick us off, Anders, and tell us a little bit about yourself and your journey to Imagimob?
Well, my background, if I look a little bit far back, I've done a couple of startups, and I've done a big, like $1 billion exit around year 2000, and then I've been in a couple of different companies, and then in 2013 we started Imagimob. And we had the vision that that everything, all devices and everything, there will be lots of devices, they will be connected, and they will have to be smart. So that was kind of what started the whole thing.
So can you take a step back and look at TinyML at a high level? Can you explain it?
Well, what TinyML is about is to kind of have artificial intelligence inference on small devices, on small chips, and typically it's an ARM-based M-Cortex MCU, which is
right.
Yeah, this is an expression. This is in the industry that's a known, but that's a very common architecture, and that means that you have the neural network or the model on the chip, and it executes on the chip using the processing power in the chip, and it's not using the cloud or anything like that. It's kind of runs on the chip.
Right. So it's really machine learning at the embedded level.
Exactly. And there are loads of different algorithms and stuff, but what we do is deep learning. So we do neural networks on the embedded level, and we can build models. So we have models that are kind of 10 kilobytes of memory, which is kind of extremely small. So size of the applications, in the embedded world, memory is always limited. It's always a constraint.
Why don't you tell us a little bit about what the company does and what your role is? I think we should set the stage here for everyone.
Yeah, so what we are doing is that we have a development platform for development of TinyML applications. And so what we offer to our customers is that they can use the platform and develop their own applications. They can deploy it on their own chips and deploy them in millions of copies, basically. It's not that easy, of course. This is part of the whole TinyML thing here. It's a lot of companies, it's a lot of technology, but we know that customers still think this is a difficult area. It's so many things that you need to kind of master in order to do this.
So you mentioned some of these applications are super, super small, right? Or the space it's taking. So what are some of the advantages of those applications of TinyML? Like what are people using it for?
There are loads of examples, but I think where we have, for instance, we have one area we work with is fall detection. And for instance, we have a product that is in the market. You can buy it in the US. And it's a watch for the elderly that has a fall detector in it. So it's a tiny software program in the watch. And once the elderly person moves around in his apartment and he falls, this application will detect the fall and send an alarm. So that's kind of, and we can see fall detection in many areas. For instance, we are talking to people that do helmets and stuff.
Right.
In the construction industry. So fall detection for us is, and we see a lot of interest there. But I think what's interesting with this watch, and the name of this product is BellPal, is that because if you look at the whole TinyML field, you will find, unfortunately, very few products that you can buy that has TinyML in them. And the BellPal watch is one of them.
Why is that? Why are there so few products? What is the challenge there right now?
I think the challenge is what I was talking about. Is it's actually quite difficult to, to build a product. You need a lot of different competencies. You need a domain expert. You need a machine learning guy. You need the embedded developer, and many companies don't have all these people allocated for these projects.
Right.
And also you need different packages. You can use TensorFlow Lite, but then you need a couple of different software packages, a number of different competencies in order to do this. So companies in general think this is difficult.
But the technology is there right now, right? To really produce some products. I'm sure there's room.
Yeah, exactly. I mean, exactly. The technology is definitely here.
Okay.
But to give you one example also for what's kind of can be a challenge is that one thing that customers underestimate is the importance of data. And to build a model, you need good data, and that can be a challenge to kind of collect. I mean, in every project we see a lot of discussions how to collect the data. For instance, if you have like an industrial machine or basically everything is kind of a challenge. So it's one thing to collect some data to build a model, but then to make it really, really have a high accuracy and work for a lot of different people, you need a lot of data. Like you might need millions of samples.
Right.
And then so collecting a small piece of data set is a challenge, but you can do that. But then to collect like a really big data set is can be very difficult for different use cases. So that's one example. That data is kind of something that customers collect data with high quality. That's something that many customers underestimate.
What about the hardware? How important is hardware development going to be in propelling the future of TinyML? Are there any challenges there? What does the industry need in terms of power, memory?
I think there are a lot of things going on there. There are a number of companies, and we work with some of them, that doing these more machine learning accelerators, such as Sentient and Synaptics, for instance, and green waves. So I think that's where it's going, and I think what you will do with that is that you can run bigger models, and you can have kind of multiple models on the same chip. So, and even also ARM. I mean, they have these new products for machine learning accelerators. So. I think hardware will be more and more powerful, and that will result in bigger models, better applications, and more applications on the same chip.
Right. So we talked about like how the machine learning is on the chip, right? And we're talking about all this data now being collected. So how is that working? Is the data being collected in, we mentioned memory, right? Nicolette mentioned memory. Is the data being collected on the chip and then transported off? Is the data being sent off from the chip? How is that working in most cases?
Well, the first step in the process is that you collect data, and then you have a specific device to collect data. Sometimes you have to build something specifically, and then you have all the data in the platform, and then you use that when you do the training.
Gotcha.
I'm not sure it answers your question, but
no, it does. It does.
Yeah.
It
Well,
does.
I guess my question to piggyback off of that, we talk about how intense that process is, that data collection, how much you need. Is there anything that comes to mind? I mean, and it could be futuristic, anything that could simplify that process, that data collection process? Maybe we're not there yet, but maybe down the road?
I'm not sure I have any good answers, but I think if a company already from start thinks that this is a device that will wherein machine learning is very important, it might include that in the design, so that data or maybe here I want to change. I think one important concept here is something we call continuous learning. So once the model is in the device, in the market, the device will continue to get data from the sensors and take that data back to the training system, so that over time the model becomes better and better. So, and I think that's also, I think you have a good point there. That's important. Continuous learning. That is what Tesla is doing. That they collect all the data in the car, they upload it to their data centers, they train new models, and then they download it to the Tesla. So it's kind of the same thing, but for embedded.
Gotcha. So it's happening at like a chip level almost.
Right.
Exactly, and that's an area we were looking very much into.
Is that similar? Is this concept of unsupervised machine learning, is that kind of hand in hand with that continuous learning?
No, that's slightly different. So
different. Okay.
I guess so unsupervised is kind of that's typically if you do anomaly detection, like say you have a machine or something, and you want to know before it breaks, you want to understand before that it breaks. So so then you don't really know exactly what you're looking for. But the model will find it. It will find the anomalies, and it will find. So that's a different. And we have projects in that area with anomaly detection for industrial companies. But in the supervised, you tell it, this is what you're gonna, this is what we teach you, and what it's learning, and this is what you're gonna detect.
Right.
Whereas go find something and then we'll sort it out. I get it.
Yeah, exactly.
So what else is going on in the world of TinyML? What else is going on besides the things we talked about?
I think it's a lot of going on in the hardware industry. As we said, there's a lot of new software companies coming up. But I think one thing that has been around for some time, it's actually when you're also doing the learning on the device. So, with our concept, like we said, you train it centrally and then you deploy it. And we can have continuous learning, but we still do the training in the platform. But for learning on device, the model learns when it is in the device, and that's a lot of interest around that.
Yeah. Now, is that going to increase? We talked about some of the size of the applications. Is that going to increase the size of the applications if the model's learning on the chip?
Yeah, it increases the amount of memory you need, for sure.
Okay.
Yeah.
A few months ago, you were at Embedded World, and you were the company was showing off some physical products that were using TinyML. I was wondering if you could talk to us a little bit about those and some of the cool projects and demos you worked on with some of your partners.
Yeah, so the one thing we showed was the Bell Pal watch. We have already talked about it. another product we showed was a safety vest for truck drivers, and that also include, fall detection and safety measures. So it has a chip here on the neck. It combines that with active light. So if something happens, it will send an alarm the same way, and the vest will start blink with an active light.
Gotcha.
So, for instance, if you are in a road in the forest or something, and that's a product. So originally that was developed together with Scania. Maybe you don't, but that's a big Swedish company. They're doing trucks. So it was originally aimed for for truck drivers, and now this project is operated by another company. But that product can be extended, to construction and like dangerous places of work, like mining or offshore or stuff like that.
Yeah,
and that's also we think it's gonna hit the market very soon. So it's kind of almost ready.
Nice.
And then we showed demos with an American company called Synaptics. And this is in the area of sound event detection and like wake word detection.
Okay.
So we have a partnership with them where we jointly go to market in these, and we are focused on this use case, sound event detection. So that can be like a glass break or gunshot. So for instance, if you have home security systems, you can detect, or things that can happen in the house, like the microwave is going, or the washing machine, or things like that. And then we also showed wake word detection. So you can, so we showed a chip that was detecting up and down, just an example. But you can teach it like any word if you want. So this is kind of an Alexa type of thing.
Right. Okay. I was about to say, like, how does it compare to things like, like doing it on the chip versus, systems, bigger systems like an Alexa or, voice commanded sort of?
I don't have the full understanding of how Alexa works, but I think Alexa, they are sending the data to the cloud for interpretation. But if you do it on the edge, you don't need to do that. You can do everything locally on the chip.
Right.
So that can be used for a lot of different use cases.
Now, do you envision, like, we're talking about machine learning, but also like AI on chips, like smart AI on chip?
So, what's the question?
I said, I guess, we're talking about machine learning, right? And having these models and, this continuous learning. Is that going to be similar to having like the AI on the chip?
Yeah, but machine learning, is a subset of artificial intelligence. So it depends on how careful you are with the definition. But machine learning is artificial intelligence, but like a subset. Gotcha. So, but again, like a supervised system can only do what you have told it to do.
Right.
Right.
So it's not, it's not general AI or something like that.
I want to go back to one thing you said when we were just talking about, something like Alexa versus a tiny ML device or product. Why then, if we're doing things like this, and I truly just don't understand certain aspects of this. If we're doing things like this, though, with Alexa, what is the benefit? Why move to this tiny ML model? Are there just certain applications that are better fit for this, or what is the benefit?
Yeah, one of the benefits, if we take, I would like to be a little careful with Alexa. I don't know so much about it, but for instance, if you send, for instance, if you understanding speech and you send it to the cloud,
Right.
Yeah, the big companies have all the data, but as you do it, so you could say it's a privacy effect that all the data stays.
Mm-hmm.
I think that can be one effect, that all the data is not with Amazon or Google. It stays in the local device.
Mm-hmm.
That can be one.
Yeah, I mean, I think too, we have to look at if it's being processed on the chip, right? It's being processed in real time where it is versus going out to the cloud and, information having to be, moved around, interpreted, and sent back in order to, for things to happen, let's say.
Exactly. So I actually wrote down some things. I think the real-time effect is, there are applications when the real time is really important, like if you want to shut down like an engine or something, then you want to do it locally. So real time is definitely, and also I think TinyML also is, if you, for instance, if you're running battery operated devices, you not only have constraints in processing power and memory size, you also have a constraint in the battery. And when you're sending data over Bluetooth or Wi-Fi or anything, that consumes a lot of energy. So I would say it's even more valuable with TinyML for battery operated devices.
Okay.
Do you think it's also going to lead to more autonomous, right? We talked about sort of unsupervised, but more autonomous, because it is happening, at the edge versus being in the cloud, all the information and being able to process it in real time. So it's more autonomous, whatever vehicles, or more autonomous houses, or more autonomous whatever. Right?
Yeah, I think so. And also, for instance, we're involved in use cases where, for instance, let's say you have some kind of alarm or something, and but it's kind of in a somewhere in the countryside, and you want maybe 5 or 10 years battery time.
Right.
Then you cannot do it if you're gonna send. Maybe this thing doesn't even have power, so then you need it to be very efficient in terms of. So and that's kind of, yeah. So I agree. Yeah, autonomous devices, and then they can operate locally, and once they find something, they can connect to the cloud and do something. But if it's do it in the cloud, you have to be connected all the time. You have to send data all the time. You have traffic costs, and it consumes power. And we are actually also talking to customers that are saying that their bills from Amazon and Azure, they do everything in the cloud. And when you start, the costs are not so big. But if you have everything there, it becomes very expensive. It's also like a cost factor.
Right. Yeah. Yeah. I mean, I think, to build like whatever true autonomous pieces, right? Whatever that is, like a robot or whatever, an autonomous vehicle is a robot, right? You need to do it. You need to do it on board, right? So you need to be able to do it at that local level to have it function in real time first, always sending everything out. Because what about when it has no, connection?
Exactly.
What about when it has no communication, right? It needs to be able to act on its, on its own, or do whatever it's doing, for safety or whatever the case is. So.
Yeah,
I get it.
So I think that's also a good. Yeah. If you're depending on the connection and the connection goes down, it doesn't work really.
Right.
That makes a lot of sense. Actually, this was very helpful for me. It was. I'm even taking notes. Well, Brian, do you have any other questions for Anders today?
No, thank you for joining us, Anders. Where can we find more about TinyML, about Imagimob, about everything?
Yeah, so about Imagimob, it's going to our website, and since last week we now have you can download the platform from the website, and we have a forever free plan. So like anyone can download it, start using it, and test it out. In terms of TinyML, you will find information because TinyML is kind of run by what's it called in English? It's not the company, but it's called TinyML Foundation. You will find it at tinyml.org.
Yeah. Okay.
It has a special type of organization, something American there. But there you will find a lot of information. They have very often, many times a week, they have something called TinyML Talks, where companies and customers talk about the product or the project. And they also run conferences a couple of times a year. So now in October, there will be a TinyML Europe in Cyprus.
Nice.
So there you'll find a lot of different companies. You will find use cases and stuff like that. And they're also on LinkedIn and other social media.
Awesome. Thank you so much again for joining us.
Okay. Thank you.
Take care.
Thank you. Bye-bye.